All right, welcome back to pre-calculus. So here we are talking about ellipses, and even though there doesn't seem to be too many parts to this, don't let that fool you. This is still going to be kind of a long problem. They're going to ask us a lot of different things. So it's a little bit more interesting because they give us something that's a little bit off-center, so that's always nice. Okay, major axis, right? 16 is a bigger, no, 25 is a bigger number than 16. Our major axis is going to be along the x value here. Okay, and then our center is not the origin. The center is 2, -4, so that's going to be a little different. Okay, so if we go back here and look at the center, we've got x minus h, right? X minus h squared over, in this case, we have a squared plus, we have y minus k squared over 16, that's b squared. So this is b squared equals 1, a squared is 25, okay, plus 1. So our center is hk. Okay, so that's pretty easy to pick out. Okay, there's not any weird stuff going on with that, so we have to deal with that. It's going to be 2. And then the problem is that the minus sign belongs to the formula. Okay, it's just the way that they happen to write it down. Okay, so it's one of those things you have to know. So it's not x plus 4, it's y minus -4. That's how you have to represent that one. So the center is going to be 2, because x minus 2, -4. Okay, because the minus sign belongs to the formula, so we just have to remember that. If it's a plus, you got to change it to 2 negatives to make that plus. That's how we're going to figure that out. Okay. So unfortunately, this is one of those problems where they have to fill everything in before they will let you type in the did I get it right button. So it's going to be a bit of a long slog here, so I apologize for that. Okay. So the vertices. Now the vertices are along the major axis. Okay, so vertices are along the major axis. And in this case, we talked about it. Like, well, 25 is a bigger number than 16. Okay, so the vertices are going to be along the major axis, which happens to be the x side. Okay, so we are going to use method of intercepts. So we're going to set y equal to -4. Okay, set y equal to -4. This is a method of intercepts. Okay, what's going to happen is that y value is going to, the y term is going to disappear. So we just have an x minus a 2, right, squared, over the 25, plus, when I set y equal to -4, what's going to happen is this whole thing is going to be a 0 equals 1. So we go ahead and solve that. That's okay. So we're going to have x squared, or x minus 2 squared equals 25. X minus 2 equals plus or minus 5. Just square root principle here. Okay, take the square root of both sides. Add 2 to both sides. So we're going to have x is equal to 2 plus 5. We're also going to have x equals 2 minus 5. So we're going to have 7. 2 minus 5 would be -3. So my vertices here, the x ordinates anyway, are going to be 7 and -3. Now the y ordinates, right, the major and minor, the vertices, they're going to be from the center. Okay, and since my center was 2, -4, we're going to be looking at something like the x ordinate is going to be 7, and what was my y ordinate? That was -4. So one vertice is at 7, -4. The other vertice is going to be at -3, -4. We're not changing where the y value is. Okay, so let's go ahead and type that in. So we're going to have that. We want, did I really do that? I think I did. Okay. So we're going to pause this from, oh no, it's right here. We're good. Okay. So all I'm going to do is just write these things down. Okay, so we have 7, -4. Okay, and it doesn't matter which order you put these in. Okay. Then we have -3, -4. Okay, -3 and -4. -4. Okay, just like we found. All right. No, it's negative. It is negative. -3, -4. Okay, now the foci, that's going to be a little bit of a challenge. Okay, so foci, that's c squared is equal to a squared minus b squared. Okay, that's the equation to find the location of the foci for ellipses. I usually give you guys this formula. Okay, it's not something I've always had the luxury of looking this up when I've needed it, but it is. Okay, so let's go ahead and figure out what c squared is. Okay, c squared is equal to, what's the big number? The big number was 25 minus 16. So we have 25, it's my a squared, minus 16. C squared is equal to 9. Thank you very much for the Pythagorean triple there. So C is equal to plus or minus 3. So it is plus or minus 3 from the center, okay, along the major axis. Okay, so there's a lot of stuff you got to remember. There's a lot of stuff you got to keep in your head while you're doing this. Right? It's actually easier with a picture than it is with a list that we've been doing like this, but that's just the way that this is. Okay, so it's plus or minus 3 from the center along the major axis. What was my center again? My center was 2, negative 4. Okay, so the center is 2, negative 4. And I want to go plus or minus 3 from 2, negative 4 along the major axis. What was the direction of the major axis? It was in the x direction. So we're going to say, okay, well, 2 plus 3, that's going to be 5. We're going to do anything with the minor axis? Absolutely not. Okay, and then 2 minus 3, so this was 2 plus 3 to get the 5. 2 minus 3, we're going to get negative 1, negative 4. So those are my foci. Okay, that's where my foci are going to be. All right, and we'll go ahead and type those in. Okay, so again, it's not the worst thing that you've had to do. You've been had to do harder things, but it is a lot to keep track of. Okay, so we are at, so already we have, that was my center, foci, 5, negative 4. Okay, and then again, it doesn't matter which order you write these in. 5, minus 4. Okay, and then we have minus 1, minus 4. So minus 1, minus 4. Okay, and then we'll go ahead and check that to make sure we got our green flag. They don't even ask us to graph this one. Okay, we'll go ahead and check it. All right, and hooray, we got our green flag. We can move on with our lives and keep going with more and more ellipses. Okay, so hopefully that was just complicated enough problem, but not too complicated. I hope that's where it fit for you as well. Again, just because you watch somebody do it, I used to be able to do like back in the 80s, you watch 1980s music videos. David Lee Roth was he would often incorporate kickboxing into his music videos. He'd do a lot of high kicks. I was so proud of myself when I could do the David Lee Roth kick. So it doesn't happen like just watch somebody do it. It doesn't mean you can do it. Got to practice. Okay, so just because you watch me do it, that's great. Practice one on your own. Okay, I will see you in the next video. Thank you.